Hello, Miss Ann here. So today, here's what I want you to do. I want you to imagine you are a city planner and you have some questions you have to answer. Here are some of those questions. Where do I put the bus station to make sure I get the most number of riders and have the most efficient route? I need to build a new building. Where would be the most energy efficient place to put it? When should the street lights turn on and when should the street lights turn off? These are all questions that can be solved by smart city technology. Now, there's a lot of definitions for what a smart city is, but really at the core, smart cities are local governments that use technology in order to better serve the people. So today you're going to get to meet my colleague Josh, and he has a smart city problem he's trying to solve. He wants to know where is the best place to put a water fountain in between two buildings. Enjoy.
Hi, I'm Josh. I work for CGI Federal here in Lafayette. I'm a director in the Emerging Technologies practice, and what my team does is help other teams get the technical resources they need to get their projects done. What I'm going to talk about today are smart cities. What does it mean for a thing to be smart? What tools do we use for smart cities or smart things? And what's the advantage of things being smart? For example, where should I put streetlights based on traffic? Or what parts of the city should have what resources at what time of the day? Those are all the sorts of things we can figure out by using machines that are connected to the internet to help us gather information. The first aspect of being a smart city are sensors. How do we gather information to use to figure things out to help make a city better? And by the way, sensors can be used in your house, in the street, in your yard, anywhere. And all those sensors can gather information, get that information to the internet, and we can use it to make things better. What's a sensor? A sensor is anything that can gather information from around itself and communicate that somewhere. A sensor can be as simple as my friend who's standing outside who's going to wave at me every time a car passes so that I know, okay, thank you, so that I know when a car passes. That's a very complicated and very expensive sensor. A very simple sensor would be me listening to see when someone turns on a faucet in my kitchen so that I can tell them either to turn it off or to keep it on. The sensors we're going to talk about today or that we use in smart city applications look more like this. This is an entire computer with some sensors built in. I can track temperature, I can track pressure, I can track electric fields and all sorts of things just by plugging this in and telling the information where to go. Other sensors can be attached to computers that are much bigger than that, but still very small. One type of sensor and small computer that everybody watching this is going to be familiar with is this. This is now we call it a phone. It used to be called a smartphone because it can connect to the internet and get information there. This phone is full of sensors that track lots of things like where you are, what angle the phone is being held, and how fast the phone is moving, what's the temperature around the phone, things like that. And by gathering that information, we can build models and figure out how to make things better. I did that as an example today with this. You can see a flashing light, you can see lots of wires and cool things. This is a tiny computer with a very tiny temperature sensor, a little screen that tells me the temperature, and this, which is a motion detector. And what it tells me is the temperature in the room and whether or not motion has been detected. So all of these sort of things, this is, by the way, powered by a battery, and I could hang it outside my door if I wanted to, for example. And I can gather that data, and at the end of the day, I can see how many people came to my house, how hot it was outside, things like that. So if I wanted to install a fan, I might know where to do it. So that's how sensors work and what they do. Why we would be interested in sensors is to gather all of that information. The next thing I'm going to talk about is what we do with that information. In smart city applications, one of the most important things that we have is the data. In an application like a smart phone, a smart car, a smart house, a smart kitchen counter, which is what I've installed here, or a smart city, is the data. Sensors, like we talked about before, gather all of this information. Once that information is gathered, it's stored somewhere. Once it's stored, we can look at it. My daughter, for example, created a list of all the bird sounds that she heard around our house. She made long marks for quick sounds, or short marks for quick sounds, long marks for longer sounds, and the thickness of the mark was how loud the sound was. So she didn't tell me that she created a dashboard of bird analytics, but that's exactly what she did. So what we would do in a situation where we have, for example, a tiny city, we would figure out first what sort of problem we want to solve, and then what sort of data we might gather for that. Now, the information we're gathering doesn't turn itself into data. This instrument, for example, doesn't know necessarily how to tell me how hot it is outside. What it does know is that a sensor is detecting changes. Once those changes can be translated by the computer into something I can understand, for example, degrees Fahrenheit. I understand that. On the sensor, what we see is a voltage. I don't necessarily understand that. So instead of seeing information about electrons inside the sensor, what I'm seeing is a number, 71.4 degrees. It's important that we keep track of all this data so that we can understand things that are happening in our smart city and make changes if it's necessary. So how does data and the sensors collecting the data contribute to making something better in a smart city? So that's our next section. The end result of working on smart city applications is that you take a collection of resources in a city, for example, 2 buildings, and you figure out how to improve life using the resources that you have. The sample problem I'm going to talk about today is 2 buildings, people walking between the buildings, and where to put a water fountain. So let's imagine in our city we have 2 buildings. People are going to work or play in one, work and play in the other, or live in one. They're going to have to get from building to building. So the city designers said we need sidewalks. So we have a sidewalk here and a sidewalk here. So we have 2 clear paths between these 2 buildings. What we want to know is, it gets hot around here, and so a water fountain would be a very valuable resource. Where can we put this water fountain so that people walking between the buildings can have a nice cool drink? Some people would say more people walk on this sidewalk. Some people say more people walk on that sidewalk. We could talk about it all day and decide which sidewalk people use more, but a smart city with sensors and data is going to allow us to discover, just by watching, which of the sidewalks is used more. Then we don't have any issue. We know which sidewalk is used more, and we know where to put our water fountain. So we're going to install a sensor that's going to look like this. It is a tree with a cute dog on it. The tree is going to measure how many people walk on which of the sidewalks, and the dog is going to store that data for us. Then we are going to analyze that stored data. So each person that walks across the sidewalk is going to leave a small trail. At the end of the day, we can look at which sidewalk has the most trails drawn on it, and then we'll know which sidewalk has more traffic. We can then use that data and that information to tell us where we should put our sidewalk. So we would allow people to use these sidewalks throughout a day. Some people would use this sidewalk. Some people would use this sidewalk. But as the day goes on, what we would find is that lots and lots of people are going to walk like this. Because they're not going to be concerned about where the sidewalks are necessarily. What they're going to be concerned about is where the shortest path is. It's very hot, and I don't want to walk all the way around that sidewalk. Where I do want to walk is where the path is the shortest, because I want to go from one cool building to another cool building. So as the day goes on and on and on, every once in a while, someone will take an outside sidewalk, and every once in a while, someone will take the other outside sidewalk. But for the most part, people are going to stay in the center, directly between the two buildings. So we have our data, we've collected the paths people are using between the two buildings, and we want to analyze it now. So I have my two buildings, my two sidewalks, my sensor, my data storage, and my data. If I look at this and I say, where are the most people walking? It's very, very clear. They walk right through the middle. That's interesting because it's not where there's a sidewalk. We planned two very good sidewalks, but that's not what people wanted to use. They wanted to use the path in the middle. So if most of the people in our city are using a resource this way, and it's not something that we anticipated, then that says we need to maybe change the way we think about it. So if I have one water fountain to install, where does it make the most sense to install it? On a sidewalk here that's rarely used, on a sidewalk here that's rarely used, or here in the middle where almost all of the traffic is? Well, the answer is in the middle where almost all of the traffic is. This is a problem that can be solved with the tools we have in a smart city. We were able to take data, we were able to store that data, communicate it, and then analyze it. It was a very straightforward problem. We solved with tools at our disposal, and we, by installing our water fountain here, we allow people walking naturally between the two buildings to have a nice cool drink on a hot day, instead of installing it somewhere where they wouldn't go and drink from it anyway. So I'm really interested in smart city problems, and I hope that everyone watching this, if you aren't already interested, become interested in smart city problems. It's a fascinating area of research and application, and I think that it's only going to get more interesting as time goes on. An interesting exercise that you can do after hearing about smart cities and seeing the tools that we use to solve problems using smart city technologies is think of one for yourself. You might have noticed that this is not a person. This is a figure. This is not data storage. It's a dog. And that's not a sensor. It's a tree. So you don't need actual sensors and an actual city to explore the concepts that you're learning about when you're reading about smart cities or about sensors. Very keen-eyed observers may also have noticed this is in fact not a water fountain. So the solution that I proposed ended up being just a model. So one way to use the things you've learned about smart cities is to think about a problem in your room, in your house, in your yard, on your street, that you think you could make better just by learning more. Is the grass in one part of your yard not growing as quickly as you'd like? Are there too many ants next to the driveway? How many ants are there? That's something you could measure. So I would challenge everyone listening to think of a problem in your day-to-day life that you think knowing more about would improve. That's the underlying strategy for smart cities. We at CGI in the Emerging Technologies practice have an ongoing project where we track air quality, and we use all the same skills that I talked about today to propose solutions to those problems, and that's something that you can also do.